All right, so we're not going far from thermodynamics. We're going into chemical equilibrium, and we're going to be talking a lot about delta G. So if delta G is not your friend yet, don't worry. You can still bond with delta G. All right. So chemical reactions can go into a state of equilibrium. And it's a dynamic equilibrium. The reaction is still happening. But if a reaction is in equilibrium, the rate of the forward reaction will equal the rate of the reverse reaction. So there'll be no net change in composition. So let's take a look at an example. So let's look at a reaction in which we have nitrogen gas and we have hydrogen gas. And they are reacting to form ammonia. Suppose we just start with nitrogen gas and hydrogen gas, and we don't have any ammonia left. So if we consider concentrations versus time, so say we start with, we have some nitrogen gas, some concentration of nitrogen gas. As it reacts with hydrogen, the concentration will decrease and then level off. We'll start with some amount of hydrogen gas, and its concentration will also decrease and level off. And in the beginning, we won't have any of the product, any of the ammonia, so its concentration will increase and then level off. So when these reactions level off, you're reaching equilibrium. The reaction is still happening, but the rate of the forward reaction is equal to the rate of the reverse reaction, so there's no net change. So the concentrations are staying the same, but the reaction is still going forward. So let's think about the case when we have pure reactants, when we haven't formed enough products yet to reach equilibrium.